Welcome to all. Here we have to discuss about the scanning tunneling microscope. So first of all we see what is microscope. It is a device which is used to view the magnified image of any of the smaller object which cannot be clearly seen by our naked eye. In 1980, John Binning and Heinrich Roher invented a new type of microscope called scanning tunneling microscope STM. In this microscope, we can obtain the images of electrically conducting surfaces in atomic scale. That is, STM is used to observe the surfaces in terms of atom by atom. The principle for this STM is the scanning tunneling microscope is the tunneling of electron between the sharp metallic tip of the probe and the surface of a sample. Here, constant tunneling current is maintained by adjusting the distance between the tip and the sample, which is shown by the figure, with an air gap of electron to tunnel. That is, the constant tunneling current is maintained by adjusting the distance between the tip and the sample with an air gap of electron to tunnel. In a similar way, the tip is used to scan atom by atom and line by line of the sample, and the topography of the sample is recorded in the computer. Here, we can get the topography only. We cannot get the complete scan of the material. So next, the construction. The figure shows how it is connected, how it is going to be scanned. There is a probe is there. The probe is start from the tip of or any point, the corner point of the material. It starts from line to line, which is indicated in the violet color line. So we have to start from left to right or right to left, line by line. So one line completed, we have to move the another line by using the probe. So from top to bottom or bottom to top, we have to scan the material. The experimental setup consists of a probe in which a small thin metal wire is etched in such a way that the tip of the probe will have only one atom. The tip is tapered down a single atom so that it can follow even a small change in the contents of the sample. If the tip is connected to the scanner and it can be positioned to X, Y, Z coordinates using a personal computer. The sample for which the image has to be recorded is kept below the tip of the probe at a particular distance, in such a way that the tip should not touch the sample. This is the main important point. The probe or the tip should not touch the sample. We have to maintain at least a small gap. A small air gap should always be maintained between the tip of the probe and the sample. It should be at least a width of any 2 atom spacing. The computer is also used to record the path of the probe and the topography of the sample in a grayscale or color. Necessary circuit connections along with an amplifier are provided to measure the tunneling current in the circuit. That is, the necessary circuit connection means we need an amplifier, we need a biasing voltage, that is the power supply we need, and positioning monitoring we need. This and all the circuit construction. Then working. The tip is mechanically connected to the scanner and XYZ positioning device. A sharp metal needle is brought close to the surface to be imaged. The distance of the order of few angstroms. If the circuit is switched on, the necessary biasing voltage is given to the probe. Due to biasing, the electron will tunnel or jump between the tip of the probe and the sample and therefore produces a small electric current called tunneling current. The tunneling current flows through the circuit only if the tip is in contact with the sample through the small air gap at a distance d between them. The current produced is amplified and measured in the computer. it is found that the current increases or decreases based on the distance between the tip of the probe and the sample. The current in the circuit should be monitored in such a way that it should be maintained constant. Therefore, for maintaining the constant current, the distance d between the tip and the sample should be continuously adjusted whenever the tip moves over the surface of the sample. The height fluctuation between the tip and the sample is accurately recorded, and as a resultant, a map of bumps is obtained in the computer. In a similar way, the tip is scanned atom by atom and line by line of the sample, and the topography of the sample is recorded in the computer. The scanning tunneling microscope does not show the picture of the atom, but it records only the exact position of the atom, more accurately the position of electrons. So we know how it is working and how it is scan the atoms and electrons. So we can come to the point of advantages. It can scan the positions and topography atom by atom and even electrons. It is the latest technique used in research laboratories for scanning the materials. Very accurate measurement shall be obtained. The magnification is up to nanoscale. Magnification is up to nanoscale. The disadvantages, even if a very small sound or vibrations will disturb the measurement setup, that is we said there should be a distance should be maintained between the tip and the atom. There should be a little bit air gap, otherwise the two atom spacing should be maintained. That is the condition to scan the material. If any sound or if any vibrations enter means the sound waves or that vibrations can travel in between the air gap, so it disturbs the scanning. So it is the disadvantages. It should be kept in vacuum. So to avoid this, it should be kept in vacuum, as even a single dust particle may damage the tip of the probe. But its cost is very high, and it's more complexity. Then applications. It is used to produce integrated circuit. It is used in biomedical devices. One innovative applications of STM is recently found is manipulation of atoms. They are used in material science studies for both bump and flat surfaces. Thank you. Here some of the applications are shown. It is used to produce integrated circuit, used to study the structure, growth, morphology, electronic structure of surfaces, thin films and nanostructures can be identified. Thank you.